Okay, so welcome to this video. I will just be doing some questions in geometry. So yeah, I might use some approaches that might be different from what you would use, but it's just to do as many questions as possible. There are 103 pages of difficult questions, so I'm hoping that from here we'll be able to identify certain skills that are very important and relevant for your test day. Okay, so this is first page. We have this question. It says in the figure AC is equal to CD. The measure of angle EBC is 45 degrees and the measure of angle ACD is 104 degrees. What is the value of x? So I want to find the value of x. So they already give us some information that AC, which is this entire line, AC is equal to CD. So we have an isosceles triangle here. Okay, but this angle x belongs to E, not so. Let's continue. The measure of angle EBC, so EBC, that's this angle here, is 45 degrees, and the measure of angle ACD, that's this angle here, is 104 degrees. Okay, so finally the isosceles triangle information they give us becomes important because 104, if you look at triangle ACD, in triangle ACD, you can call this Y. I also call this Y because it's isosceles triangle, right? So angle, if you consider triangle ACD, you're going to have 104 degrees plus 2y. It's called 180 degrees. So 2y will be equal to 76 degrees. So y is equal to 38 degrees. So each of this angle here is going to be 38 degrees. It's 38 degrees. Okay, so for us to get x, it seems we'll have to get this other angle in this small triangle here. So but let's see what else can we do. So here, actually we don't need that. So if we consider triangle, now we're considering triangle BDE. So if you consider triangle BDE, so this is what we have. Triangle BDE, 38 degrees, 45 degrees, and this unknown angle here, which you can call B degrees. So once we're able to get this unknown angle here, then of course we just subtract, apply the rule angles in a straight line and get what x is, right? So so 38 plus 45, that's 83, minus 180, that'll give you 97. So you have 90. So B is equal to 97 degrees. And you could even use the rule about the exterior angle of a triangle is equal to the two opposite interior angles. So straightforward, you can either say 180 minus 97. Okay, so 180 degrees minus 97, which will give you 83 degrees. Or you could have just done it this way, that x is equal to, which is the exterior angle, is equal to sum of the two opposite interior angles, is 38 degrees plus 45 degrees. So this will also give you 83 degrees. So whichever one you choose, you're going to get value of x. Okay. Alright, the next question, we have lines and triangles here. So again, whenever you have lines and triangles, it's really about transferring angles, applying principles, those rules to get your answer. So in the figure shown, points PQRS lie on a line segment PV and line segment RU intersects line segment XX at W. The measure of SQX, so SQX, so that's this angle here, is 48 degrees. Then the measure of SXQ, that's this angle here, is 86 degrees. And the measure of SWU is SWU, that's this angle here, is 85 degrees. And the measure of VTU, that's this angle here, is 162 degrees. So what's the measure of angle TUR? So we're looking for X. So what's the measure of this angle TUR? Okay, so first things first, let's see the easy ones to get. So from here, for 162, I'm going to straight line to complete this. We're going to have 18 degrees here. Okay, so we already have 85 here, which is a good thing. So we only need one more angle to solve this quadrilateral SWUT. So we can solve that quadrilateral to get the value of X. Or if we can get angle R, we can solve this triangle RTU to get the value of X. So whichever one is fine. So let's see, what can we get from here? So if this is 85 degrees, means this is also 85 degrees, right? So we can actually find this angle in this quadrilateral here. Let's call it Y degrees. So basically we have that 48 plus 86 plus 85 plus Y is equal to 360 degrees. So Y will just be 360 minus all of this. So 360 minus 48 minus 86 minus 85. So that will give us 141. So that angle Y is equal to 141 degrees. So from there we can find this angle here. It's going to be 180 degrees minus 141 degrees. So that's 39 degrees. So having found this, we'll actually end up using, I was hoping we would use the quadrilateral, but we can use the triangle. I think when I first looked at the question, I think it was the quadrilateral that I noticed could be used. But anyways, that's math for you. So we're using triangle RUT. So that means 39 degrees plus X degrees plus 18 degrees is equal to 180 degrees. So X will be equal to 180 degrees minus all of this. So 180 minus 39 minus 18. So that's going to give you 123 degrees. And that is the value of angle U. So if you want to use the quadrilateral, I just saw it again. So let me just show you that. If you want to use quadrilateral, means you will solve this triangle to get this part of angle X or angle S. Right? So we'll solve that triangle if you want to use the quadrilateral. So we need to find this angle. So that will be 180 minus 86. 180 minus 86 and minus 48. So this is going to give us 46 degrees. So we can use this to, again, subtract from 180 to get what you need, right? So that's 134. So 180 minus 46, 134 degrees. So you have 134 degrees here. So you can sum up that quadrilateral. So in this case, we're using a quadrilateral SWUT. So that will be 134 degrees plus 85 degrees plus 18 degrees plus X degrees equals 360 degrees. So X will be equal to 360 minus all of this. So 360 minus 134 minus 85 minus 18. So again, that will give you 123 decrease. Okay, so just about angle transfer, similar rules. Okay, the next one, intersecting lines. So what is the value of x? So here you just want to quickly solve this. So what's the value of x? So this is 106, so this will be 74 degrees. Or we can use sum of that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So basically x is equal to 74 degrees plus 23 degrees, so it can give you 97 degrees. That's x, right? You don't need to say 180 minus x then do sum of angles in a triangle. No. So most times the alternative, instead of doing sum of angles in a triangle, you can actually do it in one step using the exterior angle of a triangle is equal to the sum of the two opposite interior angles, right? Okay. All right, here we have a question. Say square A has side lengths that 166 times the length of square B. So this is square A, the bigger one, and this is square B, the smaller one. So whatever the side of square A is, so let's say this is which letter should I use now? Let's say this is D. So this is going to be 166 D, because the side length of square A is 160 times that of B. And so the area of square A is K times the area of square B. So what's the area of square A? That will be 166 squared D squared. I'm trying not to use calculator now. So and what's the area of this? It's simply going to be D squared. So you say it is the area of square A is K times that of the area of square B. So that means it's 166 squared times the area of. So the actual what's the value of K? So K is 160 squared, right? So 166 times 166, you have 27,550. 27,556. So this is value of K. Okay. All right. Now in this question, it said a right square prism has height 14 units. So height is equal to 14 units, and the volume is 2016 cubic units. What's the length in units or the edge of the base? So how do you get formula for prism, for volume of a prism? Generally speaking, is it prism? Yeah, prism, right? Okay, so generally speaking, formula for prisms, the volume for prisms is volume is equal to a base area times the height. So the base area can change depending on what shape the base takes. So if the base is square, the base area will be side squared. You can just say L squared, right? So it will be L squared times H. So if the base is a rectangle, it will be length times breadth, that's L times B, then H. So that's why a cuboid is basically a prism with a rectangular base, right? So you have that. So for pyramids, just using take advantage of the question to expound on this. The volume of a pyramid is basically 1/3 times the volume of a prism. So 1/3 times the base area times height. But in this case, you might want to call, sometimes height will become altitude, because you might also have other heights. So you might want to differentiate whenever you have two heights. You might differentiate one with altitude, but basically this is the concept. So this particular prism, we don't. It's a square prism, so it's a square, a cuboid that is basically happens. Sorry, a cube. A square. Another for a square prism. Is it a cube? No, must not be a cube. So it could be a cube, could be a cuboid. But a rectangular prism is definitely a cuboid, right? So let's find the the volume V equal to, what's the base area? It's a square, so L squared times the height H. So how do we find L? That will be V over H. Square root of V over H will be the length of the edge, right? So this 116 divided by 14, the square root of that. So 2016 divided by 14, so that gives us 144. The square root of 144 is 12. So it has length of square units, 12 square units. So in this next question, we have a triangle XYZ and angle Z is the right angle, so it's already giving us enough information to draw the triangle. So this is Z, so X and Y can actually be in any of these positions. So they said YZ is 24 units if tan X, so this is the angle now that is under consideration. So if tan X is 12/35, tan is opposite of adjacent. So opposite, the given angle, the angle under consideration is how you used to determine your opposite, right? So your opposite is basically where the eye is looking at, so where the angle is looking at, that's 24. And where's your adjacent? Adjacent is the side connecting the right angle and the given angle, or the angle under consideration, so that's 35. So if the essence is 12/35, then you have to, this opposite has to match this. So that means the original fraction will be 24/70 actually. So this opposite has to be 70. So like if you this 24/70, you have 12/35. They're asking you what's the perimeter of the triangle. So for you to get the perimeter, you actually need to find the hypotenuse, and since it's the hypotenuse that is missing, xy squared will be equal to 70 squared plus 24 squared, right? So if we find the square root of that, so 70 squared is 4,900 plus 24 squared. Don't want to stress my brain. 24 times 24, I've actually forgotten it, so that's 576. Okay, so 576 plus 4,900 to give us 5476. So what's the square root of 5476? That's 74. So xy is equal to 74 units. This is 74. So if you want to find perimeter, it's basically 74 plus 70 plus 24. So this is 98 plus 70. So this is 168. So option B is the correct answer for the perimeter of the triangle. Okay, so the next question, they say in this figure MQ and NR intersect at P. NP is equal to QP. So NP is equal to QP and MP is equal to PR. Okay, what's the measure of angle QMR? So we're looking for angle QMR. So we're looking for this angle here. So very easy question. What do you notice about this? Angle P is 60 degrees, so we can easily find this angle, which is 120 degrees. And since we have double lines on both sides, means it's an isosceles triangle. That means the angle M will be equal to angle R, right? So that's basically 180 minus 120, which is 60 degrees, divided by 2. That means this is 30 degrees and this is 30 degrees, right? Because we're looking for QMR, so it's 30 degrees.